The first thing we want to look at in this demonstration of Autodesk Vault and Product Stream is its basic and advanced searching capabilities. As a basic search, if we simply look for something like a robot, for example, we'll get a result of any files that have anything to do with a robot in them. In this case, we can even see that there is not anything to do with the robot in the file name itself. Now I've turned on a couple of extra property fields. And these can be on any custom properties you develop. That can all be turned on in. And that, in this case, in the title, is where there is some reference to a robot. So this type of search allows us to do a lot more than we typically would with only Windows Explorer. Now to take this a step further, we can go ahead and really narrow down this search to very specific aspects of a design if we like to. So in this particular case, maybe we want something with a title that would include the word block, as an example. If we do a search on that, we get several results. Now I've got a small data set in my Vault environment here, but in a production environment that could have been, 100, several hundred results right there. So if we narrow this down, we could use something like maybe the description and add some additional search criteria. And notice how it's narrowed down that set of results to just a couple of possible options. Now the neat thing about these searches, these can be saved for later use. We're not saving the results of the search, we are actually saving the query or the search criteria itself, so we can run this at a later time. So I could go ahead and save this, and I'll just call this clamp blocks. And it will be saved as a folder. So now, if I go and take a look in my search folders area, and this is very similar to search folders in Microsoft Outlook, I have an option for clamp blocks. Brings up that same saved search. Now let's take a look at the results of that. First of all, if I select one of those files, notice in the lower pane that we have multiple versions of that file in Vault. Vault will track multiple versions that have been checked in to the system. This allows us to retrieve an earlier version if we need to get at that for some reason. In this case, I'm looking at a part in the upper pane, so I want to see where that's used. Now this can be particularly important if we're trying to figure out, is this component used in more than one design or not? In this case, I see that it's only used by one assembly here, and it also shows the detailed drawings, the assembly print, and the detailed drawing where that part is referenced. If this were using additional assemblies, they'd be listed down here further in the list. We would be able to tell exactly what designs would be impacted by any change I made to this component. Now I did a simple search earlier, and then I did a search for a clamp block. If we want, without even getting into the CAD system, we can go ahead and zoom, pan, rotate, look at that model within Vault to see exactly what it is, and maybe even to do a little bit of a measurement to determine, is this the particular clamp block that I'm interested in using. Now in my case, I was doing that search so I could find an existing design that I might want to copy for future reuse. So I came up with this part. This looks like a component that is very similar, an aspect of the design I intend to reuse. So again, let's go back to that Where Used tab. And I'm going to have Vault take us to wherever that assembly is located. And I'm going to pick down below the bottom of the screen here just a hair, an option called Go to Folder. That will take us directly to wherever that referencing file resides, whether it's in the same folder, some completely different structure folder within Vault somewhere else. So Vault knows all the file relationships between referenced files. So now that we have the assembly selected, we can take a look and see there's multiple versions there. An option I didn't show earlier was this uses option. That allows us to see the CAD structure or the design structure of that assembly. So this shows all the assemblies and components that are being referenced by that design. Of course, if I do select where used again, it shows the detailed drawings that are referencing the assembly. And this is what I really wanted to do this time, was to view that assembly just to get an idea, is this really the one that I want to start out with as kind of the baseline for a new design takeoff. It looks to be the correct one. If I cared to, I could even view that in its own separate window. It could be like a full screen viewing window with the same tools I have here. So now that we've determined that this is the correct design, we want to take advantage of the same basic components of this for a new job. I'm going to use a tool called Copy Design. I'll right click on it. We'll use our Copy Design tool. This is going to bring up an interface that really allows us to pick and choose what about this design is just like the old one, and what about this design needs to be copied with new file names, or new part numbers, if you will, for future reuse. So take a look at what's going on here. Here's the assembly, and notice the preview of that component in the lower right of this window. It knows automatically that there's a drawing of that assembly, so it's going to copy that along with it. We also can see here's just some general components that are part of that design. In this case, here's a washer, for example. Now the yellow plus just means that's a component that will be simply reused. The blue icon means that is a component that is going to be copied with a new file name. So as I go down the list here, I notice that's a component. I just know off the top of my head, because I'm familiar with the design, that that is going to be changed. Same with this one here. And that. Now let's collapse some of these. But I believe the rest of these are just going to be reused, so we don't need to copy those. Okay, and one last thing I want to point out here. There is a detail individual part right here, and it's being referenced by the assembly print, but it also has its own detail drawing. Now my data set doesn't have detailed drawings of every part, but I did include one here so that you could see by copying the overall assembly, the design itself. Vault is smart enough to know that if I intend to make changes to that part, I need to make a new drawing that's automatically going to reference my new copy of this part. And that's what we have here. Now all these components that I told were going to be copied, they just automatically have a 2 in parentheses, just so the file names are different. Notice the original ones, the ones that are just being reused, they're going to be the same exact item numbers, part numbers as our original design, like all these down in the lower area. Now there's several ways we could go ahead and rename this. If I wanted, I could just select a row here and then right click and say I want to replace something about those file names. Maybe there's a job number or something like that. So we could simply say I want to replace the 2 with a underscore job 1, 2, 3, 4. And if I say replace all, you can see what happens to all that data here. Now I'm going to revert so we've got all that. Instead of doing that, maybe I'll just apply a suffix in this case. We'll just apply this underscore new nomenclature, because maybe we don't know exactly what the part numbers are going to be, or if we don't know what we want to replace all the suffixes in particular with. So I'm just going to differentiate that this is a new design versus the old one. And at this time, when I go ahead and let this continue on, it will gather up all the relevant files with all the associations between the files. All the files that are going to be copied, it will make the copy of those files. And that will be any of the parts that are going to be changed, any of the detailed drawings that go with those. And it will re-link all the references between those files. So at this point, we'll go ahead and edit this design, the new design, which will automatically launch that in Inventor for us. So now that that is opened in Inventor, one of the things I do want to do, I will just open up the assembly itself in another window. So we have both files open. But for the time being, I do want to take a look at the drawing a little bit more. So there has multiple sheets in this design, and this was a design that was set up to be reused intelligently. So I wanted to give you a quick idea of the types of things that can be done. For example, in this design right here, we have a dimension that was retrieved from the model itself. It was one of the original sketch dimensions. I want to simply edit that model dimension to change my design. Now, since I'm now modifying the design, Vault automatically knows that I don't have this checked out yet. It's asking me on the fly, do you want to check that file out? Sure, I do. Now this is going to impact other parts in my assembly. So it will ask about some of the presentation files, the other assembly files, and so on. So by changing that design, let's take a look at this in the assembly view itself. And notice that that slot now is much wider than that slide was designed for. Let me show you what's going on in the Vault window right now. So far, we've made a change to that particular component right here that's red. But I haven't updated the rest of the assembly. But I happen to know that the other components in this assembly will need to be checked out to make any real changes. So I will check out the assembly. And now that that's all done, let's go ahead and update my assembly. Notice how the design changed, and I'll save my work. So let's go ahead and take a look at how this impacts the drawing now. So switching back over to the drawing, my original view that I made my change from is still the same. We can zoom out and see that that is reflected in the other views as well. Let's take a look at some of the other components. Maybe this one on sheet 4. So now my slide, based on the changes made to the model, has automatically updated its views to match that new width as well. And if we switch to the main view, all the assembly prints will have updated to match just like the other sheets. So let's go ahead, save changes to the overall assembly and the drawing views of that assembly. And we can go ahead and check all of our new work back into the Vault, right through our built-in CAD interface. And we'll add a note just for future reference and easy searching on that information. Okay, switching back over to our Vault interface. We can now see that there's a second variation of that drawing created. We see our comment that we've added, and we can of course view those new drawings to see exactly how those changes impacted this second variation of the file. Now, one thing we can do is to switch back to an earlier variation of this design, and we'll look at the same print we were just previously viewing. And notice that we can now do a comparison and see that, yes, the version 1 of this had significant changes versus the new one we just made our modifications to. Now, once I've did this copy design, I've updated the CAD data, we've got a bunch of files sitting in Vault here with just some random file names, maybe descriptive file names. I put this _new on the end of the file, but maybe I do know the job number now. So I could do some simple searching or something of that sort here. Maybe we just say we want to find everything with an _new. And I'll go ahead, I'll select all those files, and I want to simply rename those files. Now this is something that could be very tricky in Windows Explorer, because anytime you change a file name, anything that references that file is no longer going to find it. This is a unique situation here, where by renaming these files through Vault, it automatically knows all the files that are using those, all the referencing files, and it's going to repair any of the links between the files when we rename them. So we can enter an exact naming scheme if we wanted to, or type something new in, or in this case I will use a specific naming scheme for these new files. So we could add an exact suffix. In this case, let's not do that. Let's go ahead and just manually rename them. Maybe we'll take the _new and we'll change that to job 1268. And I will apply that to the other files involved as well. And now when we go ahead and finish that renaming, it will repair all the links between the files. And give us a report of everything that happened. So going back and looking at our original folder now, notice how all those files have been updated. If I see where one of these parts is used, we can see that it still maintains all the references and relationships between all of our files.